Hello everyone, my name is Ninisha Manaswini and I am a second year PhD student from Max Planck Institute for Radio Astronomy, working with all these amazing people. And today I would like to give you a brief overview of the work that I have been doing for the last 1.5 years about the long-term broadband polarimetry analysis of this particular FRB 2024-0114A. As Ajay said, I am again today standing in between lunch and the talks. So I'll try to be first. So before the lunch bends over, let's bend some polarization angle. So given the fact that we had an amazing week of workshop where Surya has mentioned in detail about the polarimetry and the polarization angle, and many nice talks, and especially the talks in this session by Apurva. I will not go in the basics of polarimetry, but just to re-emphasize, polarization study is like sending the postcards. I wish that is that simple, but in postcards, by looking at the handwritings, we get the idea of the senders. And similarly, in this case, we can constrain the progenitor and emission mechanism by tracing the polarization angle. So in the postcard, by the stamps and the postmarks, we can trace the journey that it has traveled. Similarly here, the intervening magnetic field twisting the signal, which we can also get from the rotation measure. So what we have known in the past almost 20 years of FRB science. So given that we have detected more than thousands of FRBs, only a few percentage of them are known to repeat. And repeaters are especially valuable targets because they basically send us many postcards from the same source. That means they allow us to study them time resolved way and time variable way as well. So here I am showing the first repeater FRB 121102A, for which the rotation measure was huge. And within last 5 years, it has decreased. And if I basically put all the polarization angle from each burst one after another, then we can see that it is basically steady, and this is basically within multiple epochs. Similarly, we have also seen this plot from those who attended the last week workshop, that within 4 hours from Marthi, for this FRB 1809116P, we can also see that the polarization angle from burst to burst are not changing at all. But for this particular FRB, we have seen that the rotation measure was fluctuating a lot in the order of 700 or 500 units in multiple in a few weeks, and the polarization angle from burst to burst are also changing, and this is from Effensberg radio telescope within couple of hours. But this change is within 30 to 40 degree of angle, and of course many more. So what we got to know that even though all these FRBs are coming under the repeaters hat, but still we see diverse polarization properties. The rotation measure is huge, extremely varying or less, and the polarization angle is constant or varying a lot. So we are trying to model them using the same tool. So are they really the same object? I wish I had a straight answer to this question, but we always need more data to prove one thing. And here comes this particular FRB, as the telephone number says, 2024-0114A. And the first burst from this FRB was detected by the OG FRB monitor chime radio telescope. And after this astronomical telegram, many other groups all across the world point their telescope towards this source, detecting thousands and thousands, in the aim of detecting thousands and thousands of bursts, and they have succeeded as well. Particularly from FAST, we have detected more than 10,000 bursts from this source. And of course, many more of this. So what we know about this FRB, this is one of the hyperactive active repeating FRB, situated in a low metallicity star-forming dwarf galaxy of redshift 0.13. The dispersion measure is 527.7 unit, and it is associated with a persistent radio source. And most like other repeaters, most of the bursts are highly linearly polarized with some signs of circular polarization. So given the fact that we have thousands of bursts from this source, this basically is ideal laboratory for studying the polarimetry polarization analysis. So here my objective is straightforward, though not that simple. I would like to study the local plasma environment and the emission region geometry by tracing the variation in the rotation measure and the polarization angle. So we are also monitoring this FRB using Nancy radio telescope. This is the picture of Nancy situated in France. I've never been there. I put this picture from Google. But thanks to Dante and Jeff, who helps a lot in ongoing this campaign known as Extragalactic Coherent Light from Astrophysical Transients, or in short ECLA. And in this campaign, we basically monitor roughly in the order of 20 FRBs on a monthly cadence in the frequency coverage of 1230 to 1738 megahertz. Fun fact, in French, un éclat means a burst. So we have recorded roughly 800 bursts over the past year from this source. We are also monitoring this source using Effelsberg radio telescope using multiple receiver, but I will emphasize now the P217 receiver. By the way, I have been to Effelsberg radio telescope, fantastic site. I will highly recommend if you get the opportunity to go there. And this is a picture from my mobile. So thanks to Pranav, who has taken the observation in the first half of 2024, because in the second half, the telescope was in maintenance. The frequency coverage is roughly similar to as of Nancy, and we have recorded roughly 100 bursts from this source with just 2 epochs. So given the fact that the frequency coverage of this telescope are same, but the backend is different, so doing the polarization study from both of these telescopes can complement each other and also can act as check source, which I will show you in the later slide. So let's start with rotation measure. So this is the plot of almost 1 year, where in the x-axis I am showing the rotation measure, the time, and the y-axis I am showing the rotation measure. And you can see that from burst to burst or from epochs to epochs, the rotation measure is fluctuating a bit, taking the error bar into account, but it is not varying extremely. The blue data points are from Nancy, as we have multiple epochs throughout the year. The green data points are from Effelsberg, and the size of the data points shows the signal to noise ratio. Now this vertical rectangle basically shows the high burst activity region, which was also detected by FAST. So let's zoom into that region. This is a very busy plot, so let me walk you through. So the x-axis of this plot is showing the elapsed time since the arrival of the first burst. The y-axis in the upper plot is showing the rotation measure. The purple data points are the burst-specific rotation measure, and the horizontal line is basically average RM. And you can see it is fluctuating a bit without any particular manner. You are taking the error bar into account. The middle plot is showing the polarization fraction, where the linear and circular polarization fraction is shown in red and blue color respectively. And the bottom plot is showing the weighted mean polarization position angle for each burst. And the colors basically show the same thing as of upper plot, where the purple shows when the bursts are defaraded to the mean to the burst specific RM, and the green shows when they are defaraded to the mean RM. And here the histogram basically shows that polarization angle from burst to burst are all over the place from minus 90 degree to 90 degree. By the way, this is from 13th March of 2024, where with Nancy we have detected 60 bursts within 40 minutes of time interval. Now let's zoom into this plot and let's take the time axis into out of the picture. So this is what we see. So here the different colors are basically showing different bursts, and this is the polarization position angle. Per beam polarization fraction, linear and circular in red and blue are shown in the upper panel. And this is basically showing that from burst to burst, the polarization angle are varying a lot. It is not like what we have seen from Surya's plot in the FRB 1809116B. And the vertical dashed line is showing the boundary between two bursts, and the gray highlighted region is showing if the two bursts or multiple bursts have happened within 1 second window. And particularly interesting one is this one, where we have seen that two bursts have happened within 10 millisecond time window, and there is a almost 90 degree jump between the polarization angle. So we have done the same thing for multiple epochs throughout the year, taking the Nancy radio telescope data into account. This is another epoch from 16th of March within 30 minutes. Though we don't have that many bursts, but still the polarization position angle from burst to burst are varying. But here, from the Effelsberg P217 receiver, on the same day, we have 2 hours of data where we have also seen that the same thing is happening from burst to burst, polarization position angle is varying without a particular Hessian. So this is just the gallery of some of the epochs from the Nancy. So now we have seen that the time-lapsed motion of all these FRBs only in L band. But to disentangle the propagation effect and the intrinsic emission mechanism, we have to look through the wide-angle lens, and that's where the new UVB receiver in the Effelsberg radio telescope comes into play, where the UV stands for ultra broadband, where we get the instantaneous bandwidth of 1.3 to 6 gigahertz, and the flexible backend allows us to vary the time and frequency resolution as per our convenience. Here I am showing a single pulse from the magnetar J1810, where you can see this single pulse is basically acquiring entire frequency space from 1.3 to 6 gigahertz. So we are also monitoring this FRB using new UVB receiver in the first half of 2024. So within 4 epochs, we have recorded almost 800 bursts from this source, thanks to Pranav and Florian, who have taken the observation. By the way, we have also submitted the paper recently, taking the statistical analysis of all these bursts in the archive, so do check them out. And here I'm showing basically 3 plots out of these 800 bursts, where you can see, even though the FRB bursts are narrowband, they are still acquiring the entire frequency space, like chunks of entire frequency space from 1.3 to 6 gigahertz. And no single burst from this source was detected, which was spanned across the UVB bandwidth. So now let's move, do the same analysis in one of the epoch where 23rd May 2024, where we have continuously monitored this FRB for 6 hours, almost 600 bursts in this epoch. And in band 1, with the central frequency of 1.6 gigahertz, we can see that the polarization angle from burst to burst are jumping a bit, but it is not taking the entire space from minus 90 to 90 degree. It is fluctuating a bit, and the per beam polarization fraction is shown here. And of course, there is a few outlier in this plot. So we have also seen this band in the Nancy and the P217 receiver. Now let's move to the upper bands in UVB. So this is band 3 with the central frequency of 3.5 gigahertz, and we can see that the polarization angle from burst to burst are steady constant. It is not varying at all. Of course, there is a few outlier. And the per beam polarization fraction, linear and circular, is shown in this plot. Now let's move further away, and in band 4 and band 5 with the central frequency of 4.6 and 5.6 gigahertz, though we don't have that many bursts in this upper band, but still we can see that the polarization angle is steady from burst to burst. So again, what we have learned from this FRB is the rotation measure is fluctuating a bit, taking the error bar into account. And the polarization angle from burst to burst is varying in the L band, but when we go to higher and higher band, in at least one epoch, it is constant. So I can only touch the tip of the iceberg because there are a lot of models, I assume, and then I will leave the floor to any suggestions and comments on this. So if we consider the geometric model, then of course the pulsars and the rotating vector model comes into play, where based on our line of sight and the magnetic and the spin axis, we see this S-shaped swing. But as we don't know the period of this FRB, we don't know if this is what is happening. But maybe Paz can comment on this better. But if we are the magnetic field and the angle between the magnetic field and the spin axis is small, and we are basically looking into the polar region like the aligned rotator, then this can be explained by when the polarization angle is varying a bit from burst to burst in the lower band. But then, how can we explain the minus 90 to 90 degree or the fluctuation in the polarization angle in band 1? So let's move into the plasma propagation effect, where the X and O mode comes into play, where in one mode the plasma is propagating along the magnetic field, where another mode it is propagating perpendicular to the magnetic field. And depending upon the intersection of the line of sight with all these modes, we can see these jumps between burst to burst polarization angle. And here I'm showing the plasma birefringence effect, where the X and O mode can, depending upon our line of sight intersection, we can see different polarization angle from burst to burst. So I'm again back to the open questions that I have asked. Can a unified model explain the diversity in polarization? Or maybe we need family of emission mechanism, binaries, or something else entirely different. And especially what makes this source special in terms of showing the stable and rapid variation of emission geometry. So now I will leave you with the conclusion. The real science starts where the predictability ends, but the launch is predictable. So, thank you.
Thanks for the interesting talk. I'm sure there are many questions. Let us start. Questions running? Yeah, Raja, please.
So you have shown like burst to burst variations. Have you seen some variations within the burst, like intra-burst variations?
Yes, we have seen that. I think that is because when the linear polarization is dropping and circular polarization is rising, we are not seeing the flat polarization position angle within the burst, but it is a bit slanted.
Okay. Yeah, thanks.
More questions? Maybe I can ask one. So you have recorded around 100 bursts from Effelsberg and 800 from Nancy, if I'm not.
Yes.
Okay.
Effelsberg P217 receiver.
Yeah.
Yes.
So my question is, any of these were simultaneous? And if yes, then do you see similar polarization properties there, just as a?
Yes. So here you can see, this is 16th March 2024 from Nancy. And this is also 16th March 2024. And it is basically showing the same thing, but given that the Nancy doesn't have a lot of burst, but still it is the same.
Still, like if a given burst, if you pick up, then it shows similar behavior.
Yes.
And you say some places there are abrupt like changes of polarization, but some places it is gradual also, right?
Yes, but I don't know.
Here, maybe in that 6 hour continuous plot, yeah.
Oh, you mean this?
Yeah, say this one, yeah.
Yes, I mean, here the time axis is not correct because I'm basically concatenating all the burst polarization angle together, but in the similar, like consecutively also. So of course, these bursts have happened one after another, but yeah, there is some variation like this from burst to burst.
More questions? Yeah.
Very interesting result, Ninisha. So it's showing that actually once you're going from L band to the higher frequency, the stabilities of PPA is increasing. So in addition to that, have you also seen any other properties that are actually more turbulent in the low frequency? For example, the Faust density, energy variations, those bursts?
Energy variation. No, I don't have the. I think there is for the Nancy data, the 800 burst, the paper is in preparation. Jeff is working on that from McGill, and it will soon be submitted to the archive, but I don't have the.
Sure. I think
yes.
we can talk about it.
Yes,
later.
yes,
yeah,
yes.
Thanks.
Yeah, we have one. Yes, yeah, please go.
Hi. So I have a question. So in your different bands, B1, B2, B3, you saw that there are some outliers in the PPA angles. So are they same outliers across the band, or are they same burst, or it's completely random burst?
What do you mean by same burst?
So for example, you have some between
here.
Yes. There are some outliers in the next plot, in the different band.
Yeah.
So the outlier Are they correspond to the same burst? Mean,
No,
or same time?
the same time, I don't know. Maybe I will look into detail because all these are preliminary and we are still looking into it. But there are some bursts which are also going from multiple bands, But there is no similar same burst which are entire UBB bandwidth. No single burst is detected which are spanning entire 1.3 to 6 gigahertz. But there are, of course, some of the overlaps in band 4 and band 5 or band 1 and band 2. Of course, we will look into that in details. These are the preliminary ones, yes.
Let's just check if there is any question from online participants. If you have any questions, please unmute and ask. Okay. If we don't have any question now, yeah, we are near to lunch. So let us thank Ninisha for the wonderful talk and let's go lunch.